Hello guys and welcome back to our YouTube channel. So in this video we are going to see the data analysis question, that is question 7 of the Northwest Regional mock that question students have also demanded for the solution. Okay, now let us follow it step by step and take this as your last revision and make sure you will be. So the materials that you need to work here is simply you have a graph paper, you need a graph paper, you need a calculator, you need your pens and so on and so forth. Anyway, as you are going through the video and you see how to use all of them, you need to also use things like that. Okay, now let us say the question is that the resistance R of a thermistor is related to its absolute temperature T by the equation R equals to R naught exponent of that. Now, where R naught is this value, so please always try to circle this type of things. The resistance at temperature T naught and Q is a constant under certain conditions in an experiment carried out in the laboratory. The values of resistance R and the temperature theta were obtained and the result recorded in the table shown below. Now they're talking about this experiment that is related by this equation. Here are the values. This is what R in mega ohms. This is mega ohms. We have theta in degrees Celsius, right? And these are the values down the scale. Now the first thing they are saying that is plot a suitable graph from which the values of T naught and Q could be obtained. Hence, determine the values of Q and what is the graphical significance of 1 on Q. Voila. So that is the question. So let us begin. So the first thing you do is this is my own equation that I've just written. R equals to R naught into all of this. This is what I copied from the board after we read the question. This is the first thing. This is what I put on the board as my notice, as my note. Now the second thing again, the first thing you do is what you identify your unknown variables and your known variables. When you identify your known variables, you mark them with a tick. That is, they have given us R in that table, and they have given us R naught to be 5.5 times 10 to the that they have not given us Q. We should mark an X there. They have given us T, that is absolute temperature, and they are giving us T. We can find it. Then they say T naught is a T naught and Q is what we are able to plot the graph and determine. So these are the two things that we don't know, and these are the three things that we know. Then now the second thing is here, you know that you have y equals to mx plus c. How many variables do we have here? 1, 2, 3, 4. How many are you having here? 1, 2, 3, 4, 5. So you have to really make sure you have at least you are having your two unknowns that you don't know. Is it clear? Make sure the equation is having only two unknowns. Yes, or maybe it can be type error, which I think it shouldn't. Now the second is to determine the unit of each term. Now the unit of R will be what? Ohms, right? It's already given in mega ohms. R naught was also 5.0 times 10 to the negative 5 ohms. T is in what? Kelvin, temperature. T naught is also in what? Kelvin. And Q have to be what? Kelvin. How did I get the units for Q? Okay, look up here. Here we are having that. Here we are having that e raised to the Q into 1 on T minus 1 on T naught. E raised to this have to be dimensionless. If I open the bracket, I'll get e to the Q on T minus Q on T naught. If this T is in Kelvin as temperature, then this thing have to also be what Kelvin for this thing to be dimensionless. And this one is also in Kelvin, that is temperature. This will also have to be in Kelvin. So you see the units for Q will be Kelvin, such that it will cancel and will end up having e to the power a unitless quantity or a unitless number. So that's how I just got the unit for the Q and T naught. Because after all, another way is that T have been given to you as temperature. Now to know the unit of 1 over T, now since they are subtracting these two, it means they should have the same units, right? So if all of this term is per Kelvin, then this has to also be in per Kelvin. So that's another way. So after that, the next again thing that you have to know is when you are going for data analysis, the next thing is now how to make your equation suit what you have to do. That is, you plot a graph. Now we have been given the equation that the unknowns are raised to a certain power, and we can't. Our y equals to mx plus c does not have anything raised to a certain power, right? And all the degrees are simply what 1 of our y and x, right? Now the next thing again we have to do is to really try and make this thing to look in this form. The first thing, see that our Q is up there, our T naught is up there, so we have to bring them down. And the only property in mathematics that allow you to take a variable up and bring it down is what we call the logarithms. Now the logarithms, there are also two. We have the common logarithms and the natural logarithm. So I'll work with the natural logarithm. So now I've taken the natural logarithm on the left hand side. Also take it on the right hand side. What you do on the left, you do on the right. Now you have taken it to the left hand side. We can now say that here we now say that ln arrow equals to ln arrow naught plus ln into cure into 1 on t minus 1 on t naught. Since we know that ln of AB is equals to ln of A plus ln B. So I've just separate them from what? From the ln of arrow naught, all of this is my A, this is my B. I've just separate them and have this A and B. Now, the next thing again, I've just simply bring down the power because I know that this one ln A to the n is equal to any ln A. I'll just simply bring down all that power down. You see how the log property is really helping us here to go about this. Now the next thing again is now you now have ln r equals to ln r naught plus cure on t minus cure on t. I've just opened this bracket and then I've just said that ln e is simply 1 because this is log ln e base e again. Any log to the base of that log is simply 1. That is ln 3 base 3 will be 1. Sorry, log 3 base 3 will be 1. Log 10 is already in base 10, have to be equals to 1. So if you just see ln without any base, then know that the base is e. If you see log without any base, know that the base is 10. So this is what you have to know, right? Just like you see normal numbers. If you see 2, know that 2 is in base 10. If it is in base 3, we write 2 in base 3. Okay, so those are small hints. Now the next thing again you do is now your statement of plot. Since you have linearized everything right, now the next thing is your statement of plot. You say that a graph of a statement of plot, a graph of ln arrow against 1 over t, that is y equals to mx plus c. This is my y, this is my m, this is my x, all of this is my c. So your statement of plot is a graph of ln arrow against 1 on t gives a straight line with a constant slope cure and an intercept on the ln arrow axis, which is ln arrow naught minus cure on t naught. Do not put it. Students didn't even tell me in class. So we have ln arrow naught minus cure on t naught. So that is now our intercept. This is the intercept. That is y is equals to ln arrow. Then m is equals to cure. X is equals to 1 over t. Then your c have to be in ln arrow minus cure on c naught. Very correct. Now the next thing you go now, you now add the variables that you don't have. That is, you are now having on your answer sheet. You have to now put arrow. Since you need arrow, they give you, so you have to copy it again. But they were putting a mega ohms. They have just decided to put 10 to the 6, 10 to the 6, 10 to the 6, right? And then the temperatures are here in Celsius as well. Now ln arrow, I'll just take the ln of 2 times 10 to the 6. I got 14.5086. You have to do it to at least 4 decimal places. If you're not doing it to 4 decimal places, since the question is coming to 1 decimal place and you follow it, you will have a wrong thing. And maybe this column is not the one that will explain that to us. Let us just continue. So the ln 5 times 10 to the 6 gives you this. Ln 7 times 10 to the 6, that is 7 million, give you this. Ln 11 million, give you this. And so please don't forget the mega ohm that was here. You consider, even if it is not mega, if it is 10 to the negative 2 that you have written there sometimes, you still take it. Now the next thing again, we need our T, and our T is what? At the absolute temperature, that is temperature in Kelvin. So 10 plus 260. So T in Kelvin is equals to theta in degrees Celsius plus 273. It was supposed to be 273.15, but we just take 273 at our levels. So now they are in 10 degrees plus 273. This was 283, and then 20 plus 273, and so on. You feel all the value right at to the 100 value. To that up to the 100 value that I got 373.0 degrees Kelvin. And each color you put the unit. I've not put units here. Why is that? We'll discuss that in the next slide. So here I'm now having 1 on T. The reciprocal of this, that is 1 on 283. I got the value. Now it being what? In per Kelvin. It be in per Kelvin. Very correct. Now the next thing again we're gonna do is we have found the values and you're writing it to 4 decimal places. You see what I was telling you to 4 decimal places. If you write it to 2 decimal places or 1 decimal place, you just be having 0.00, 0.00, 0.00, 0.00, and then what are you plotting? So you needed to 4 decimal places. That is why I've just written this 4 decimal place. Very important. Even if it is in your lab manual, if I does not see 4 decimal places values, I always mark it wrong. Okay, now you now go to now, why does ln arrow has no unit? Why did I not put unit in ln arrow? Okay, now recall the unit of Q have to be Kelvin. which is slope. Slope is what I wrote there, which is slope. Now, a graph of lane arrow, if I put lane arrow is in ohms, then a graph of 1 over t, which is in per Kelvin. So my slope will be now equals to what? My slope will now be equal to change in the vertical axis, change in lane arrow, all over change in 1 over t. This one can go up, so you can put change in t into lane arrow, right, which is slope. Slope equals to that. But we said that slope is what cure. And what was the unit of cure? Kelvin. What is the unit of t here? Kelvin. What is the unit of arrow? Ohms. Are you seeing that Kelvin here is equals to Kelvin ohm? Do you agree with that? I put a question mark. So this is to tell you that if you take the log of a number, it is dimensionless. So don't put the unit. So this is the answer to this question mark. I gave the students in class. So now you now see how the dimensions are helping you to know how to even fit units on your quantities, right? Okay, now let us move to the next thing. The next thing again now, the number seed point is graph paper. Now, when you move to your graph paper, the first thing you need to use is your ruler. And how do you use the ruler? Which ruler do you even need? A ruler that you place it like this diagonally and it will occupy all the graph paper. That is a ruler that you are prescribed to use. If you go and take a ruler that you place it like this, it will be something like this. Maybe those 15 centimeter rulers, then know that you are not ready for the data analysis. So you need a ruler that you place it like this. This is your graph paper. You place the ruler like this. You place the ruler like this and make sure it goes across. It should start maybe from here to here, and then that is a good ruler to continue. So now the next thing we're going to discuss is all your values question mark. So are all your values positive and positive? Are they positive and negative? If you have your ruler, are they negative and positive? Are they negative and negative? So now I'm just trying to mention about all the 4 quadrants. Which quadrants do we need to work with? If all the values are positive, you will then begin from where? From the bottom here. You have your 0, your y-axis, your x-axis. All the values are positive. But what if some of the values for the x-axis it is positive, while for the y values are negative? If all the y values are negative, then you begin your graph from up here, and then you will come down. You have your y values increasing downward. Then you have your x values like this. But if some of the y values are positive while others are negative, you'll be having like this. If all your y values are negative, and this is your x values which are positive, all your y values are negative. But if some of the y values are negative, others are positive, you'll be having 0 here. You'll be having the positive y values. You just put positive y values, then the negative y values, then your x values, and so on. Then you move again to same scenario. What if you have the x values to be negative? X values to be negative now. We are talking about this. If all the x values are negative, you can cut your graph like this. This is 0. The y values are positive, and the x values are negative. You go like this to the left, then number 1, and so on. That is your 0. So increasing this direction to the left, right? Now, the next other thing again we're gonna talk is what if increase the test of the eraser. Okay. Now, the next thing we're gonna talk is what if all of them are negative and negative, or some of the x values are negative. We'll be having something like this 0. Some of the x values are positive, some are negative, but for the y values are all positive, something like that, positive y. You begin with your graph right to the bottom. Then the next thing again we're gonna talk is what if all of them are negative. If all of them are negative, you begin your graph like this. You begin your graph like this. 0 will be here. You will have your x-axis this way, your y-axis this way, but it is negative, negative, 0, negative, negative downward, negative in this direction. So it depends on that. Then you dress your paper. But in our case, let me see, we are having the 1 over t values, all of them are positive. We are having our arrow values, all of them are positive. Very correct. Now, if you come now, you add your, these are my values here I plotted. Now the next thing now is to plot. And to plot, I've just simply shrink my values to write 3.5 times 10 to the negative 3 to have a whole number here. Right, I have obtained it. Then now we move now to what we call your scale. Now to talking about your scale is what we, if you go to scale, you know that on the vertical axis you have 22 squares, on the horizontal axis you have 18 squares, and you have to take 3/4 of 22 by 18, that is the surface area of your graph paper. When we talk of taking the 22 over 18, this is what we mean. Taking about 3/4, it means if this is your graph paper, your first plotted point and your last plotted point, if you find the area covered by those points, it should give you 3/4 of the graph paper, that is 75% of your graph paper. We don't mean that you should come and start from here and go here, that, and you tell me that you have plot this is 3/4 of your graph paper. All of these are empty spaces, so we should not see that again. The next thing, let us now discuss on how you should get your scale. Getting your scale is simply using your values like this, the currencies where 1 franc exists. We are talking about coins: 2 franc, 5 franc, 10 franc, 25 franc, 50 franc, 100 franc, and so on and so forth. So those are how we use to determine our scale. And now we talk of 1 franc, we can still talk of 0.1, 0.001, things like that. There are also multiples of that. When we talk of 2, we can talk of 0.2, we can talk of 2.0, and so on and so forth. Or in summary, you are just saying that your scale should lie between 1, 2, and we can talk of 25, 2.5, 0.25, and so on. You can take the decimal place, flip it around the values. You can be 10, 0.1, or 10.100, or 1000. You can add zeros, or you can multiply by an integer. Is it okay? There is no 600 franc paper or coin, so don't use it. Don't use a scale of 6, don't use a scale of 3, don't use a scale of something like 4. Is it okay? Then when we talk of scale, what do we mean? We just mean what we call increment. A scale means increment. How should I increase with my graph paper? Should I be increasing by 1, by 2 units, or by 5 units, or by 10 units, or by that? So the increment is what we call a scale. Is it clear? So your increment should be either 1, 2. And when we talk of scale of 1, you can talk of 99, 100, 101, and so on. It does not mean that you begin from 1, please. If you say a scale of 2, it does not mean that you begin from 2. It can be 8, 10, 12, 14, 16. When we talk of scale of 5, it does not mean you begin from 5. It can be from 0 to 5 to 10. It can be from negative 10 to negative 5 to 0, and so on. That's the meaning of a scale. That is a multiple. That is your increment, or a constant common difference. Then now, I have these values. The next thing I have to select my scale. My minimum value, let me start with the horizontal axis. My minimum value is what? In this column, I think it is 2.7. 2.7, which is down here at the last value, which is associated with 99. Then the maximum value is what? 3.5. 3.5. Now you put your minimum value to 2, and you take your maximum value, you meet the next whole number, 4. Take it to 2 means that I've include 2.7. I've taken it to 4, I've include 3.5. Don't come and take this one to 2.2, then this one to 3. No. If you take this one to 3, you have already neglected all the values that is from 3.1, 3.2, 3.33. So you just increase to 4, right? Then now you take your how many squares are on the horizontal? 18. 18 divided by 4 minus 2 gives you 9. That is 18 over 2 gives you 9. But 9 is odd. You can still use 16. You subtract 2 from here. 16 over 2 gives you 8. So it means I can have my graph paper in such a way that I'll be having this axis, I'll be having, let's say 2 here, 3. After 8 lines, I'll be having 3. After another 8 lines, I'll be having 4. That's, I've used 16 squares out of 18. And that is very, very good. Now the next thing is, am I beginning from 2? No, I'm beginning from 2.7. So and where am I ending? I'm ending around 3.5. So what I will do, I'll be shifting this value to the left, also shifting these values. That is, I'll start maybe from 2.6 and maybe end to 3.5. Please, if you have a graph paper, you can work that and see. I'm increasing here and reducing. It shows that my first plotted point and my last plotted point should give a scale. I should not come and put 2 here, starting from 2.7 somewhere around close to 3, somewhere here. Allow all this space for what? It does not mean that I begin from origin. Is it clear? When plotting your graph, and I'll tell you why, and we'll do everything and you'll see. So now this is what I did. I started from 2.6, 2.7, 2.8, 2.9, 3.0, 3.1, 3.2, 3.3, 3.4, 3.5, and everything entered. Right. Now the next one again, I'll go to the vertical scale. On the vertical scale, I will just write, I'm having what? The lowest value is simply 14.5 to 1 decimal place when you are plotting, and the maximum value is 18.4. As usual, we put our minimum value to 14, our maximum to 19. We have 22 squares up. 22 divided by 19 minus 14 gives you 4 point something. No, I can take subtract 2. I'll be having 20 over 5, which will give me 5. So I'll be having, after each square, if I write here 14, after 4 squares, I'll write what? 15. After 4 squares, 16. After 4 squares, 17, 18, and up to 19. Then the next again, I'm beginning from 4.5. I can throw some of the values if I like. But for 14 and 14.5, I think we can begin from 14 or 14.5. So if I begin from 14, I'll be having 4 squares, I'll have 15, 4 squares, I'll have 16, 4 squares, I'll have 17, 4 squares, I'll have 18, 4 squares, I'll have 19. And that is it, very clear. This is 19. And now in between, please don't fill values here. Don't. I don't. So we have don't fill values here. Please make your work to look neat. Don't fill values here. Don't fill values here. So we write from here. We don't fill here. We put 14.5. We don't put here. We put 15.5. We don't put here. We put 16.5. We don't put here. We put here 17.5. And we don't put here. We put here 17.5, 18. We don't put here. We put here 18.5 and so on. Then now we move to plotting. When plotting again, the only way you do that, you have consumed a lot of time. You take a vertical, you take your transparent ruler, 30 centimeter ruler. Let us say you want to plot for the point 3.2, which is coinciding with 3.2, 3.2, 15.4. So now you take your ruler, you place it like this. That is, you place this edge of your ruler to be very, very horizontal. And then you use your hand. Then you use your hand like this. You use your hand, you extrapolate from the other point. You see here we are having what? We are looking for 15.4. So this is our 15. You know that 15.5 is here. Right? Let me see. This is 15.4. 3.2, 15.8. Yeah, so we are having 15 here. We are having 15 here. We know that here will be 15.5 will be here, and then 16 will be there. So we know that in between here, we now move to know the significance of a single square. So you just take 14.5 minus 14 dividing by 10. This one gives you 0.5 on 10, which is 0.05. So one small square for the vertical axis is 0.05. Let's do the same for the horizontal axis. 2.7 minus 2.6 all on 10. I'm dividing by 10 because I have 10 small squares between here and here. Here and here I have 10 small squares. And we get this to be 0.1 over 10, which is 0.01. So this is the increment on the horizontal axis, while this is the increment for the vertical axis per square. So now if I take this plus this, I'll get 2 of this. I get 2 squares to be 0.1. That is 0.05 plus 0.05. 2 squares will be 0.1. So we have 15. 2 squares we have 15.1, 15.2, 15.3, 15.4, 15.5. You see, we move again similarly, and we go to 15.8. Then you move, you extrapolate from there. Okay, you extrapolate from there like this. You see where we are now. We extrapolate. We come now. We meet our ruler that was here. You just mark the point. You take your ruler again. You place it here, and you move with your hand. You come here. You mark, and you do that for all the points. And this is the skill. These points are not included. This is the line of the point. And then you draw now your line of best fit. Right? You draw the line as such. Then after that, you now move to your calculations to calculate your slope. Now for the slope, please let me just get the points so that we can calculate the slope together. Okay, well, let us continue. So remember here on the bottom, I've not mentioned, we have put the 10 times 10 to the negative 3. That is, since I've just worked with these values, you also indicate it with the unit per Kelvin lane. R has no unit. I justify it behind. So now let us come here. We know that our slope have to be Q. And this is now the points I've removed from my graph. I've read the first point here, excluding plotted point, not plotted point. You read point on your line. This is the first point, and this is the second point that I read. So this is the first point, and this is the second point. Now, for the first point, it has coordinates. That is for the horizontal axis first before the vertical axis xy. So we have the plot and just say x1, x2, please, x1, y1. Please don't write x1, y1 in that graph. Then let us say x2, y2. Now we know that our slope have to be changed in y. That is our y. So I'll just take this point to be 0.2 minus. So we're having 14.5 minus 18.55. It has no unit. I divide by the next one down. It will be 3.49. Since I started with this, it's only this x2 again minus x1. 3.49 minus 2.63. But this one has unit, which is, and it also has that 10 times 10 to the negative 3. Remember, we shrink it to make it look good per Kelvin. That is the unit. So now we just simplify all of this, and I obtained 4-4.7093 times 10 to the negative 3 Kelvin. The per Kelvin goes up. We have, times 10 to the negative 3 Kelvin. And that is that for the value for our cure. And now you can say cure, which implies cure will be equals to, you can take to one decimal place, negative 4.7 times 10 to the negative 3 Kelvin. This is now your answer. Now to calculate now your intercept, you did not begin from the origin. So especially for the horizontal axis, you did not begin the one on it from the origin. So your intercept is wrong. Don't read the intercept here, you have a wrong value. So you have to go and calculate it. And calculating, you use any of these your points. So we'll use P1. So we'll say P1 with coordinate 2.63, 18.55. Because I think you know how to extract the coordinate, right? Okay, now having that, we know that this is associated with our 1 over t, and this is our lane r. Remember, we have our equation that lane r is equals to q into 1 over t plus lane r naught minus q on t naught. So now I can just call all of these quantities to be c. So now we are having lane r will be equals to q into 1 on t plus c. Right, where c is simply lane r naught minus q on t naught. Now I can take any point. I will take this one, so I'll be having 18.55. That's my value for my lane. Will have to be equals to q, which is just what I found, negative 4.7093. Please work now with all the decimal points. Is it clear? Because you are finding the value for t, don't use the approximate value for q. All that multiplied by 1 over t, which is 1 over t, which is having a coordinate of 2.63 times 10 to the negative 3 per Kelvin. And this one is also in what? Kelvin. Are we there? Plus our c. So now we just make our c the subject. And let me post, and so our c will now be equals to 18.55 minus this 20. So let me take my calculator and do. Okay, this is the value I got for c. C is equals to 30.935459, something like that. This is my calculator, popo. Now, okay, now, so this is what I've just done to enough. Let us consume much time. So c equals to ln r naught minus q on t naught, and I make t naught the sub q. I take this term this way, and then I take this other one the other way. Be negative. This one become positive. Then I took t naught over q will be 1 on this side. So t naught will be simply just q on all of this side. There's a negative here. Now this negative c naught is what we calculated behind here to be 30 point, but the negative of it, I will simplify all of this. We got negative 4.7 times 10 to the 3 Kelvin for q, dividing by negative this, and we got positive 264.38 Kelvin. So this is what we got. So now I want to tell you that, okay, now so see that there's asking us to calculate the significance of 1 over q. You know that 1 over q has unit 1 on Kelvin, and from r equals to r naught into 1 plus this is added to this, so this have to be dimensions. It is added to 1. So t is already in Kelvin, alpha have to be in Kelvin. So this 1 over q is just like alpha, and alpha here is the coefficient, is the thermal coefficient of resistance. So now of the resistor now, so q 1 over q will just be the thermal coefficient of our thermistor. So that is how you can know the significance by the units. So now let us go and discuss one very important thing for this video. Okay, now here in front of you is the marking guide. This is their own marking guide. They plotted a graph of what? They linearized their graph and plotted a graph of ln r on r naught to be q onto 1 on t. That is, they plotted a graph of ln r on r naught into q on this. That is, they transported this term and applied ln r minus ln r naught to be that, and they got that, and they got their slope to be what? Q to be what? Their Q simply 4.64 times 10 to the 3, and we got 4.7. I think we are also correct, just of their roundings, which I'm not always d'accord with. And now using the point that they calculated their C, and also came and calculated their C to be 17.61, and we got to be negative 17. Now they took negative Q on all of that, and they got 263, and we got 265. I think we are more accurate than them. But there's a nice conclusion here, please. Okay, now please try and reason this. So I come back to the question where we answered. So it means that they are saying that if ln r equals to this, they just brought this into the right hand side, and they said jump combine this with division, loss of log, and they're having this, and they plotted a graph of this against 1 on T and got their slope. Now their slope will be changing in R on R not all on changing 1 on T. That will be their slope. So their slope will be equal to this, and their slope will be Q. So now they are telling us that changing this equals to slope. So it means this on this equals to, I think the change in this equals to this. So now does it mean that T ln R on R not equals to T ln R, because that is the same thing we had, or C log A over B equals to C log A? I would like mathematicians to prove this to us whether that will be correct. So thanks for watching and have a great day. Brought to you by Mohamadu African Center for Excellence.